Hello, everyone. We're going to continue our study of sequences and series today with just focusing on arithmetic sequences and partial sums of arithmetic sequences. Our goal today is just going to be able to recognize and write the nth terms of arithmetic sequences and find nth partial sums of arithmetic sequences. And then we'll pick up again the next day with a little bit more of that. So to get started, we'll have to first discuss what an arithmetic sequence is. An arithmetic sequence is a sequence that is arithmetic, obviously, but it's arithmetic when the differences between the consecutive terms are the same. So the difference between the terms of an arithmetic sequence is called the common difference. And that's a term you might remember from Algebra 1. So I'm not sure if you have that same terminology, but that's what we'll use here. And that seems to be a pretty common terminology. So to find the nth term of an arithmetic sequence, we can use this approach. So our first term, a sub 1, is just a sub 1, okay? And then from there, to get each successive term, we're going to add d. So to get a sub 2, we would take a sub 1 and add d to that. So we can rewrite that as a sub 1 plus d. Now to get a sub 3, let's look at this for a second. So a sub 3 is really a sub 1 plus d again, right? Because we're taking whatever was the previous term here, which is this right here, and we're adding d on again, which when we simplify that becomes a sub 1 plus 2d, and that's what you see written right here. To find the fourth term, we can continue this kind of process. We take the third term, which is a sub 1 plus 2d, and we add d again. So that's going to give us, and I apologize, that should be equals, not plus. A sub 4 equals a sub 1 plus 2d plus d again, which then simplifies to a sub 1 plus 3d, and that's what we see here. And we can continue this. If we want to find the fifth term, we'll take the fourth term, which is a sub 1 plus 3d, and we add another d to it, and that gives us a sub 1 plus 4d, and that's what we see here. The goal is, can we find a way to write a sub n? So I want to find an overall representation of an arithmetic sequence. So look at our pattern and pause the video for a moment and see if you can find that pattern. Okay, maybe you came up with something like these two things I have written down here. I hope that what you noticed is that the fifth term had only 4 times did we add d to the first term. The fourth term, we added d 3 times to the first term. The third term, we added d twice to the first term, and so on and so on and so on. So the number of times that we add d is 1 less than the term we're trying to find. So that translates to this: a sub 1 plus n minus 1, that's whatever is here, minus 1 times d. Now you can write it this way, or a lot of times you'll see it written with d out in front. Either one is appropriate. Okay, so from this point on, we're going to be using this approach whenever we talk about finding the nth term of an arithmetic sequence. And notice, I've just kind of highlighted here that d represents our common difference. It's the difference between any two subsequent terms in the sequence. And then a sub 1 just represents our first term. All right, so for each sequence described, we're going to write the first 4 terms and then the expression for the nth term. So for our first one, we have the arithmetic sequence. We know it's arithmetic, so we know we're adding something, whose common difference is 4, and the first term is 7. So this means this is how much we are either increasing or decreasing the sequence by. If it says it's positive 4, that means we're adding 4 each time. So our first term is 7, That means we then add 4 to 7. So 7 plus 4 is 11. So that's the second term. And then we can take 11 and add 4 and we get 15. So that's our third term. And then we can take 15 and add 4 to get 19. So that's our fourth term. So there's our first 4 terms. So 7 is our first term, we'll call it a sub 1, and 4 is our common difference, which is d. So we have our first 4 terms. That was easy enough to generate. But now let's write the nth term, an expression for the nth term. And this is where it can get a little tricky, but we'll just use the formula that we wrote up above. So to write the nth term for this particular sequence, we're going to take the first term, a sub 1, which we were given as 7, so equals 7 plus our common difference. Our common difference is d, that's 4. So our common difference is 4, 7 plus 4 times n minus 1. Now you can leave it like this. That's perfectly okay. We could clean this up a little bit. So let me kind of move up here and we'll clean it up a little bit. And by that I mean we can distribute 4. So we could have a sub n equals 7 plus, and then when we distribute the 4, we have 4n minus 4. And then we could write this as 7 minus 4 is 3 plus 4n. All right, and so that's another way we could think about that. You'll start to notice some patterns as we look at this expression written in both ways. This makes it very easy to see what our first term is and what our common difference is. This gives us our 0 term, but it still gives us our common difference, and that's the only difference between these two expressions. They mean the same thing, and they're going to give us the same sequence if we plug in values for n. All right, so let's go ahead and write out the first few terms of this arithmetic sequence. This time we are told our first 2 terms are 2 and negative 3. So this is a1 and this is a2. So if we were to write out the first 4 terms, we would have 2 and then negative 3. Now, the difference between those 2 terms, to get from 2 to negative 3, we have to subtract 5. So if I subtract 5 again from negative 3, I get negative 8. And then if I subtract 5 again from negative 8, I'm going to get negative 13. So those are the first 4 terms of my sequence. Now, if I want to write the expression using our formula that we wrote up here, I need to know what the common difference is. I know what A1 is, and I wasn't explicitly given the common difference. However, I know A1 is 2. This number that we figured out that we're subtracting every time, that's actually D. So we can write our expression for our sequence. We could say a sub n equals the first term, a sub 1, which was 2, plus d. Now this time d is negative, so minus 5 times n minus 1. That's one way to write it. If you wanted to simplify it and write it with, no parentheses, we can do that over here to the side. We'd have a sub n equals 2, distribute the 5, the negative 5. And what you end up with is this. So either one of these are acceptable for your expression. It just depends on what you want to see in your expression. Do you want to see term 1 or do you want to see term 0? You choose. All right, so this one gets a little interesting. This time we're going to talk about the third term, and then the common difference is 1/4. So, third term, and I wrote 1. So this time what we know is, so we don't know A1, we don't know A2, but we know A3. We know A3 is 3/2. And then we don't know A4. But what else we know is that the common difference is 1/4, which means I have to add 1/4 if I'm going forward, which ends up giving us 7/4. Okay, so now that's going from a smaller term to a larger term. In other words, from A3 to A4, we add 1/4 because that's our common difference. Now, if I'm working backwards, what I know is that I have to take whatever A2 is and add 1/4 to it to get 3/2. But if I want to work backwards, if I want to say go from the third term to now the second term, I have to reverse what I'm doing, kind of do the inverse. I'm going to subtract 1/4. So instead of adding 1/4, I subtract 1/4. And then I would have here 3/2 minus 1/4 would be 5/4, right? So now I've got this pattern that I can kind of look at in either direction. Now, if I'm going to go to the from the higher term to the lower term, once again, I'm going to subtract 1/4, and that'll give me 4/4 or 1. So check it. If I start here with my first term and I add 1/4, I'm going to get 5/4. If I add a fourth again, I'll get 3/2. And if I add a fourth again, I'll get 7/4. So this works with the situation we were given. Now, there's a lot of other ways that you can go about figuring this out. That's just one. Okay, so if I want to write the nth term, okay, so my first term I just figured out was 1, and I'll add whatever my common difference was, which we figured out was 1/4 times n minus 1. If you wanted to simplify that, you could. Either one of these would be fine. It's up to you if you like to do that or not, but if you do, so go ahead and try that on your own, pause the video and come back, make sure we get the same thing. So you should have either a sub n is going to be 1 plus 1/4 times the quantity n minus 1, or a sub n could be written as 3/4 plus 1/4 n. Okay, this is written for the 0 term. This is written for the first term. All right, let's try a couple more. Okay, so this will be a little bit different. We have the fourth term of an arithmetic sequence is 20, and the 13th term is 65. So now we've got a big gap in between. We want to try to write the expression for the nth term of the sequence and then write the first 10 terms of the sequence. Okay, so we're going to substitute in some values into this expression to help us solve this problem. So let's just write out what we know, okay? We know that a sub 4 is in fact 20, okay? And we know that the 13th term, let me write that over here. We know that the 13th term is 65. Okay, well, there's a couple ways we can do this. So if I look at my expression here, I have an expression for any term in the sequence. Well, guys, okay, so let's look at one way we could do this. We can actually set up a system of equations, can't we? Because look, we know a sub n and we know n. Well, here n is 4, so we could plug 4 into both of those places. Here n is 13, so we could plug 13 into both those places and then simplify it a little bit. So let's look at what happens when I do that. Okay, so for this expression, let's say I've got a sub 4 equals a sub 1 plus 4 minus 1 times d. Now there's a couple things in this still that we can simplify. A sub 4, we actually have an expression for that. I know that a sub 4 is just 20. So where I see a sub 4, I can rewrite that as 20. So let me try that. Oops. So I would have 20 instead of a sub 4 equals a sub 1 plus 4 minus 1 is 3, 3 times d. Okay, that's not bad. Now let's do the same thing for the second value that we were given. Okay, so a sub 13 equals a sub 1 plus 13 minus 1 times d. I'm just replacing all of my n's in this expression with 13. Now once I've done that, look, I know a sub 13, I have an expression for that, don't I? It's 65. So that expression is just 65. So let's go ahead and rewrite the whole thing, and it would be, instead of a sub 13, it's going to be 65 equals a sub 1 plus 13 minus 1, well, that's just 12 times d. Now what you have here is a system of equations, right? It's a very simple system of equations. We should be able to solve this system. In fact, the way it's set up right now, I should be able to just subtract those two equations from each other and eliminate a sub 1. So I'm going to do that. Okay, so I'm going to subtract. I'm going to say 20 minus 65, and that's going to give me negative 45 equals a sub 1 minus a sub 1, that's going to be 0. And then 3d minus 12d is going to give me negative 9d. So really what I have here is negative 45 equals negative 9d. Oh, that's an easy equation to solve, right? So I divide both sides by negative 9, I get 5 equals d. Well, that's really helpful. Now I know at least this part of the equation. I still need to figure out what the first term is, but that's the great part about our system of equations, right? I can take one of those original equations and plug in now what I know. So let's go ahead and take that equation, that first one, 20 equals a sub 1 plus 3. Now we figured out that d is 5, and I get a nice equation. 20 equals a sub 1 plus 15. Subtract 15 from both sides, I get 5 equals a sub 1. Well, now I've got the first term. So now I have this part of my equation as well, which is great because that's all I need in order to write the expression for the nth term. So let's go ahead and do that. Okay, so a sub n is going to be our first term, which we found was 5, plus n minus 1 times 5. Now I could rewrite that a little bit. In fact, I'm just going to rearrange this because I like to have the 5 in front there. 5 times n minus 1. And I could rewrite that if I wanted to distribute the 5 and I'd get, a different expression for a sub n, but this is fine as well if you want to leave it like this. So here's our expression for the nth term. That was the first thing they were asking for. The next part is to write the first 10 terms of the sequence. Well, now that we know the first term is 5, and we know our common difference is also 5, we can just start writing out those terms pretty easily. We're just counting by 5s here. And we would have our first 5 terms that look like this. So there's our first 5 terms. All right. Let's try one more and then we'll be done for the day. All right, last one. So this time I want us to find the 15th term of an arithmetic sequence that begins with 2 and 9. So theoretically, guys, we could write out all of the terms up to the 15th term and we could get it pretty easily, but I don't want to do that. I want to start with the fact that I know that my first 2 terms are 2 and 9. This is a sub 1 and a sub 2. And to get from 2 to 9, I had to add 7. Well, that tells me my common difference. That's the difference between the 2 terms. It's plus 7. I have a sub 1, and I have my common difference. I have everything I need to write my general form of that equation. So let's go ahead and write the nth term. So I take my first term, which I know because I was given is 2, plus the common difference, which is 7, times n minus 1. Now that's the nth term. That's how we generate any term of the sequence. But here's the thing. I was specifically asked to find the 15th term. So if I want to find the 15th term, I plug in 15 for n. And then it's just a matter of some pretty quick arithmetic here. So 2 plus 7 times 14. Okay, and that's going to be, so a sub 15 equals 2 plus 98. So we get the 15th term is 100. Now, it might seem like that was more work than necessary, but it's probably going to be easier than having to add 7 a whole bunch of times until we get to the 15th term. Either way, you're going to get there, but just imagine if I had said, hey, find the 115th term now. That's when you're going to want to write this equation first and then use it to find that term. All right. Hopefully this all makes sense. Get on Classroom, check out the check-in and extra practice for today, and make sure you get that check-in submitted in the next day or so. All right. Great job, guys. Talk to you soon.